Good day, everyone. This is Teacher Win, and welcome to another science lesson. For this video, we are going to learn about atmosphere. So, before we start, let's try to know first our objectives or our targets. For one, we are going to learn about the composition of the Earth's atmosphere. Number two, so we are going to compare the Earth's atmosphere from the other inner planets, so that includes your Mercury, your Venus, and your Mars. Let's define first what is an air pollution. Then we are going to pinpoint the different sources. Finally, let's talk about these particulate matter or PM. Before we go deep to our lesson, so let me ask you first this warm-up question. So what sets the Earth apart from other planets and makes it possible for us to live here? There are 8 planets in our solar system. So why do you think Earth is like very special? Earth is also called as the Goldilocks planet. So why do you think, what makes Earth very special that makes it possible for us to live? Why not can't we live in Mercury? Why can't we live in Saturn? So what do you think, M1? Okay, so basically that's because of our atmosphere. So this picture is our planet Earth, and the other picture is an apple. So how do we connect these two pictures? So let's define first what is an atmosphere. So you just imagine an atmosphere is like a cloth or a blanket that protects us. So like for example, you are going outside in a very cold weather, and then you are not wearing your clothes. So when you go out, what do you think you will feel? Okay, exactly. You will feel very cold. In this analogy, so we can compare that the skin of your apple is like a blanket or a cloth that protect the meat of the apple inside. So also with your atmosphere, so we have here like a thin air that acts as like your blanket, okay? And then which also provides protection for the earth. Protection from what, teacher? So protection from your ultraviolet rays, or shall we say extreme heat from the sun. Okay, what else? Also, your atmosphere is protecting us from this meteoroid, your asteroid, or shall we say your space rocks that is trying to enter into our atmosphere. So what will your atmosphere do? So it will like burn those space rocks. Okay? So I repeat, the skin of your apple is like an atmosphere. It provides protection of the meat inside it. And that meat is like the earth. Okay? So I hope you now understand the analogy of this apple and the earth. Now, at this point, our atmosphere is made up of air, or shall we say the mixture of different gases. So what do you think are the gases that make up our atmosphere? Okay, so let's try to find out by watching this video. Okay?
Sid is walking in a garden with his mother. Mama, I always enjoy being in a garden. I feel so refreshed here. Yes, son, even I feel the same. The air in the garden is really refreshing. Sid's mother is absolutely right. Wherever there are trees, the surrounding air is quite clean and fresh. It is because the trees release oxygen into the air, which is an integral part of air. Trees help in maintaining the level of oxygen in the air, which is important for the survival of living beings. Air does not only contain oxygen, but there are several other gases present in it as well. In fact, air is a mixture of gases. Let us now find out what gases air is composed of. The biggest component of air is nitrogen. It comprises around 78% of the air. Out of the remaining 22%, 21% of air is composed of oxygen. So, nitrogen and oxygen gases form about 99% of air. The remaining 1% of air consists of several gases, including carbon dioxide, argon, helium, neon, hydrogen, ozone, and water vapor. So kids, now you know what air is composed of.
Once again, what are the gases that make up our atmosphere? Can you tell me, M1? So very good, M1. So our atmosphere is made up of different gases, by which there are two major gases that comprise your atmosphere. So we have here first your nitrogen, which is around 78%, and then your oxygen, which is 21%, and the other gases, which is your 1%. So what do you think are these other gases? So that includes your argon, your carbon dioxide, your water vapor, your hydrogen, your neon, your helium, and methane. Okay, so let me just tell you some fun facts about these two major gases. We have your nitrogen and your oxygen. So if you talk about your nitrogen, I'm not sure if you can still remember our lesson about plants, because nitrogen is very important to plants, especially for the growth of the plant. Because if the nitrogen of plant is very low, so basically, so they will not grow that tall, or the flowers are very small, or the fruits are also very small, and then you might observe that the leaves are also yellowish. However, farmers can use fertilizers to increase the level of nitrogen. But again, if it is too much, then it's also bad to our environment. So those excess nitrogen fertilizer might go to the rivers, which can toxic the aquatic environment or the water environment near that place. Okay? Also, your nitrogen is very important to us because your nitrogen is used to make your DNA, or shall we say the blueprint of life, or shall we say the genetics that controls our characteristic or our traits. Also, let's go now to your oxygen. So as we all know, so oxygen, so this is the gas that we need for us to breathe. The living things need this oxygen, especially animals and humans, to survive. Also with your oxygen, so it is necessary for combustion. Can you still remember the word combustion? So combustion means burning. So please remember that the burning process, so it always involves the presence of your oxygen. Now, how about these other gases? So in other books, we call it as your trace gases. Trace gases. So it's T, R, A, C gases. Okay, so we call it like trace gases because we cannot find them in a very big amount. Now, let's try to compare our atmosphere with the different gases of your inner planets. So your inner planets, so that includes your Mercury, your Venus, your Earth, and your Mars. So your Jupiter, Saturn, Uranus, and Neptune, so they are your outer planets, or sometimes called as your gas planets or your Jovian planets. So we will focus more in our inner planets, or the terrestrial planets, or planets that has the presence of soil or rocks. So I want you to pause the video and think, what do you think are the major gases that you can find in Mercury, in Venus, and in Mars? So again, I want you to pause the video and try to think, what are the major gases that you can find in Mercury, in Venus and in Mars. Okay, so let's try to find it out by looking at the table. So using our internet resources, so we found out that for Mercury, so it has no atmosphere. Why do you think? Okay, so that's because your Mercury, if you look at the picture, it's very close or very near to the Sun. So if you can still remember our lesson about heat, so if you can still remember our lesson about heat, heat increases the movement of your molecules or these tiny particles, right? So as it moves very fast, so some or most of its molecules will be escaping from Mercury. That's the reason there is no atmosphere in Mercury. Next, we have your Venus. So in our internet research, so we found out the two major gases. So that includes your carbon dioxide, 97%, and your nitrogen, which is 3.5%. And if you look at also with Mars, so we have here like two major gases, which is your carbon dioxide and also your nitrogen. However, if you look at the table very closely, so let's focus more on Venus and also with your Mars. So we found out that these two planets, they have carbon dioxide as the main gas of their atmosphere, right? However, it's the opposite in Earth, right? It's nitrogen. So why do you think? What's the reason why Venus and Mars, they have more carbon dioxide compared to Earth? So to answer that one, let me just share to you some information about how does an atmosphere form. So we will be focusing more on the Earth, okay? Since Earth is the only living planet in our solar system, okay, so scientists believe that the Earth was made 4.5 billion years ago, wherein for the first billion year, so it is believed that there were like very strong volcanic explosion or volcanic eruption, by which there is like a very concentrated amount of carbon dioxide, just like your Venus and your Mars, okay, with a very small amount of water and other gases, okay. So during the course of time, for a very long period of time, so these gases condense, or shall we say, especially the water vapor, so it groups together, by which that grouping formed into an ocean. So remember that one thing that the scientist is looking for the science of life is the presence of water, right? So with your ocean there, so life starts to bloom. Now, with the presence of life, so the carbon dioxide started to go down because you already have your plants, right? So your plants absorb carbon dioxide in order to make your oxygen, in order to make your food, which is also known as your photosynthesis, right? And also another reason why your carbon dioxide started to go down was that some of these gases were like locked or being trapped in your so-called your fossil. So also, somehow your ocean also plays an important role in dissolving this carbon dioxide. So now I hope you understand why is it your Earth does not have so much carbon dioxide compared to your Venus and also your Mars. So the Earth's atmosphere is complex. So that means that it is not the same anywhere on Earth, and it's not also the same as we move going up. Okay, so as we can see here, we have here the cities, we also have here the factories or industries, we also have here the agriculture or the farms, we also have here your animal farm, We also have here an ocean. We also have here the forest and other ecosystems. Okay, so we are going to study this picture as we discuss more about your atmosphere. So an atmosphere has 5 layers. So let's read first these layers. So we have here your troposphere, stratosphere, mesosphere, thermosphere, and your exosphere. So we will be learning more about these 5 layers in our future lessons about atmosphere. But I want to emphasize more about the troposphere and your stratosphere because it is mentioned here in our picture. So in your troposphere, so it is the bottom layer of your atmosphere, meaning it's nearer to the sea level as we move up. Okay, so this troposphere, so what can we find here? So in your troposphere, all of these weather conditions that are happening right now on Earth, you can all find it in your troposphere. So like your typhoon, your tornado formation, your snow formation. So everything is happening in your troposphere. Next, we also have here your stratosphere. So in your stratosphere, this is where the presence of your ozone layer can be found. So your ozone layer is responsible for protecting us from the harmful rays of the sun. So by which you have here your ozone gases. So also in your stratosphere, I'm not sure if you are familiar with riding an airplane and then the pilot will announce somehow that the plane is now flying at 33,000 feet. So that 33,000 feet that is already in your stratosphere. So why is it most of the airplanes would love to fly in this area? Okay, very good. So that's because in your stratosphere, there will be less air turbulence. Air turbulence meaning the bumpy experience or the bump experience as you are riding your airplane, right? So basically, so if you are the pilot, so you will be aiming to an area of your atmosphere that has less air turbulence or less weather condition. So this boundary here, this line here that separates your stratosphere and also your troposphere is what we call your tropopause. So let me just write the spelling. So it's tropopause. It's Tropopause. So again, your tropopause. So that is the boundary between your troposphere and also your stratosphere. Next, let's try to study more about the picture. We have here the cities and then your industries that are releasing these gases like your carbon dioxide, your carbon monoxide, your methane gases, your black carbon, your CFC. Okay. And then also in the ocean, you have also here the release of your sulfur. Also, so we have here your arrows. So these arrows here will represent your convection. So I hope you still remember convection. Hot air goes up, cold air goes down. Okay. So in the process of your convection, some of these gases will stay in the troposphere. So meaning as the hot air or as the gases move up higher, okay, or far away from the ground, so some of these gases will go back down to Earth through the process of your convection. However, there are also like gases that are starting to form here. So like for example, this chemical formation that will make your O3 or your ozone production. And also there are also some gases that can escape and bypass this tropopause. So we have here your water vapor and also your CFCs, or your chlorofluorocarbon, or your chlorofluorocarbons. So fortunately, we are not using, because these CFCs were used before in air conditioning unit and in your fridge. So the bad effect is that it will destroy, or it can destroy, our ozone layer. So I hope it's now clear to you. What do you think will happen? Imagine you are the engineer, M1. So what do you think will happen if there will be now lots of cities, lots of factories here? So what do you think will happen to the concentration of your nitrogen, the concentration of your oxygen, and other trace gases? As we build more cities, as we build more factories, as we have more transports, what do you think will happen? Okay, so very good. So there will be changes in the concentration of your gases. So it can be that your carbon dioxide, before it was only like less than 1%. So as we build more factories, so maybe it can become, or start to become like 3%, or maybe it's increased to like to 5%, by which what will happen to your oxygen and your nitrogen level? So they will also start to go down, right? So these cities, your industries, your transportations, okay, so they can cause the changes in the level of your atmospheric gases. And one of the changes is what we call your air pollution. Now, moving on, let me ask you this one, M1. So what do you think of when you hear the word air quality? So I want you to pause the video and try to think, what is the word air quality? So if we talk about the air quality, or the quality of air, so we are talking about the condition of the air in a certain place. So let's try to look at some of these pictures. We have here the sandstorm in Morocco, the smog in Asia, and the clear day in Los Angeles. So which picture do you think you would like to leave? So obviously you want to live in a clear day in Los Angeles, because if you live in Morocco, wherein there's lots of sandstorm, so you might develop a health condition like your asthma, right? Or maybe if you want to live in Malaysia, so it is now covered with this smog. What is smog? So that is smoke plus fog. Smoke and fog, we call it as your smog. So this is smog. So this is not the natural fog that you can experience in a very cold morning. Okay, so this smog here are produced by the factories, by the cars. So those are the smokes that combines with your fog. So wherein it's very dangerous if you are exposed in a longer period of time with this smog. So therefore, M1, the air quality is not the same all over the planet, right? So as you move to cities like Bangkok, right? So, or in Samut Prakan or in Pathum Thani, so there will be more factories, there will be more cars, so the quality of air there will be bad, right? However, if you move to provinces, like maybe in Phuket, or maybe in Chantaburi, or in Rayong, wherein there are lesser factories or cars, so you will be having like a good air quality. Now, let's continue. So what is this air quality in connection to your air pollution? So what is an air pollution? Okay, so pollution means dirty. So air pollution is like dirty air. So there are different types of your air pollution. So we have here your particulate matter, and also your gas phase, So let's begin first about particulate matter, or let's call it PM. So this particulate matter, so these are your tiny particles or your dust So wherein this dust or tiny particles comes in different sizes. So if you look at the table here, so we have here the numbers on top. So as we go to the right, so the size gets bigger. And as we go to the left, the size gets smaller. Also, your particulate matter, so we are measuring it in terms of microns. So what else? The particulate matter also comes in different labels. So we have here your PM10, PM2.5, and PM1. So as the number gets smaller, the size also of that dust or particles are getting smaller. Like for example, we have here your PM10. We have here your pollen, your spores, right? Particulate matter that is between 2.5 to 10. So we have here your mold, your allergens. We also have here your mite, right? Dust mite. And also we have here less than PM1. So we have here your cat allergens, your suspended atmospheric dust. It can be your smog here, your soot also, right? Also, I want you to know also M1 that the size of your particulate really matters as well. Why? Because if the PM size is bigger, so they tend to stay less time in the air, so they will fall down to earth. However, if the size, like for example, your PM 2.5 or your PM1, which are very, very tiny, so they tend to stay longer in the air. So the danger of getting into our body is increased. Now, M1, how about COVID-19? Can you consider it as a particulate matter? And if it is a yes, so what do you think is the size of your COVID-19? Okay, very good, M1. So your COVID-19 is an example of your particulate matter because your COVID-19 is an example of your virus. Okay, so wherein, as we can see in the graph, so your viruses, so the size of them is very, very tiny. It's less than 0.1. So that's why your coronavirus is very dangerous, Amwana, because of its very small size. So if you look at the slide here, so this is PM10, right? So the size of PM10 is bigger than the size of your PM7. And your PM7 is bigger than the size of your PM2.5. How about your coronavirus? Where is it? So your coronavirus is here. So can you just imagine the size of your coronavirus versus to the size of your PM10. So they are very, very tiny, M1. Huh? So that's why M1. It's very important that you have to wear the correct mask that can filter the coronavirus. So if you want to know the size of the mask, so it should be less than 0.1 micron so that the virus cannot enter into your body. Because if you will just wear ordinary mask, especially the cloth mask like for example, a mask that has a Demon Slayer design or a Hello Kitty or the Raymond design, so the holes of those masks are bigger than the coronavirus. So the virus can easily enter into your body. Okay? So in your gas phase, so let me just share to you some of these gases and some of the sources. So for your carbon dioxide, so we can find it in your biological respiration, meaning breathing. Humans that breathe, animals that breathe, so they release or make carbon dioxide. Also, we also have here your combustion or your burning, which is complete. So wherein, if we combine here your fuel and your oxygen, so they will become your water and releases your carbon dioxide. We also have here your nitrogen dioxide, which can also be found in combustion or your burning. We also have here your volatile organic compounds, or VOCs. So wherein it can be found in your incomplete combustion. So we also have here your cleaning products at home and also your paints. And also your carbon monoxide, which can be found in your incomplete combustion, as well as your photochemical reactions. So this is your example of your photochemical reaction, wherein this is your oxygen combined with your carbon monoxide and combined with your sunlight. So it will produce your ozone and your carbon dioxide. So we know already the different types of your air pollution. We have your PM and your gas phase. So what do you think are the main causes of your air pollution? So we have here different sources of your air pollution from your pollutants. So pollutants are substances that can cause the air to become dirty. So we have here from your combustion or your burning. So this one is your wildfire. We also have here your man-made activities. So we have here your cars, or the smoke from the cars, your motorcycle, your buses. We also have here your factories, your industrial activity, and your manufacturing. We also have here your natural sources, your trees, because they release carbon dioxide, and we also have here the explosion or the eruption of your volcanoes. We also have here the mechanical generation, just like the dust or your sandstorm formation. Now, I'm not sure, M1, if you have tried to observe this one as you wake up early in the morning. So, if it happened one day that you observe this kind of formation, what do you think is the meaning of this formation? Do you think it is a bad thing or a good thing to see this one? Okay, so this kind of phenomenon is what we call your temperature inversion. Temperature inversion. So what will happen in your temperature inversion is that it normally happens in the morning, wherein the temperature around the area is still colder than the afternoon, right? And with our basic knowledge that hot air goes up and cold air goes down, so if the temperature here is colder, so the old air or the pollutants will stay longer in this area, right? Because it's still cold, right? So what do you think is the air quality in this area, especially in early morning? Okay, very good. So it will be very bad. Okay, so this is like the downside of your temperature inversion, because it will trap the pollutants. So can you just imagine, M1, if you have here lots of factories, so that means there will be lots of pollutants that will be trapped in your temperature inversion. So therefore, temperature inversion can cause a bad effect to our body, because as you walk here, so you are inhaling more of these pollutants, which can make you sick. We are now in your short quiz, so this will check your understanding of our lesson. Okay, number 1. Which of the following is not a major component of the atmosphere? A. Nitrogen. B. Oxygen. C. Chlorine. D. Argon. You can pause the video to think of the correct answer. Okay, so the answer is letter C. It's chlorine. Next, number 2. What caused the amount of carbon dioxide to decrease and the amount of oxygen to increase in early atmosphere? So, do you still remember the history of the atmosphere formation? So I want you to recall, I want you to remember. You can play back the video if you want to. A, animals. B, plants. C, cooling. D, warming. Okay, so very good, M1. So the answer is letter B. That's because of your plants. Because your plants absorb carbon dioxide, so the level of carbon dioxide in the atmosphere goes down. And also, your plants are making your oxygen, so the oxygen level will go up. Next, number 3. Which of this was responsible for helping to reduce the amount of carbon dioxide in the atmosphere? A, the oceans. B, the dinosaurs. C, evolution of mammals. D, planet formation. You can pause the video and think of the correct answer. Okay, so the answer is letter A. It is the ocean. So your ocean dissolves your carbon dioxide. And number 4. This is an example of your cloth mask. So the cloth mask cannot filter A, dust, B, pollen, C, spores, D, COVID-19. So your cloth mask has a bigger hole than your COVID-19. So therefore, your cloth mask cannot filter your COVID-19. So letter D is the correct answer. Finally, we're almost finished. So I'll be giving you this one as your homework. So the first homework is you have to write in your science notebook the impacts of your air pollution to your health, to your climate change, and your aesthetic. So again, what do you think are the bad effects of your air pollution to your health, to the climate change, and your aesthetic? This aesthetic, it means like the place. So, like for example, if Bangkok or Pathumthani has lots of air pollutants, so what do you think is the air quality? What do you think Pathumthani or Bangkok look like? Okay, that is more of your aesthetic. And second question. So, you can search on Google or some news report articles about the PM 2.5 outbreak that happened in Thailand last year. I think that was around January 2020. So I want you to identify which provinces were affected during the PM 2.5 outbreak, and then what industry is prevalent in those provinces affected. So question B is like, what are that industries that causes your PM 2.5 to increase? And then letter C, what did the government do to minimize the PM 2.5 outbreak? So in Pathumthani or in Bangkok or in Ayutthaya, so what did the government do to reduce the PM 2.5 level in the air? And then, as an M1 student, so how can you help Thailand? Or if Thailand is so big for you, okay, how can you help your place to minimize air pollution? So you are going to write this one in your science notebook. So that ends our lesson for this video, M1. So I hope that you've learned a lot about the atmosphere. So if you have any questions, you can just message me directly online. And also, once you are finished with your homework, don't forget to upload it in your Google Classroom. So once again, thank you very much for watching, M1, and have a great day. Goodbye.